Hello, this is Jonathan Kane, KM4CFT. In today's video, I'll be showing you how to build the KM4CFT end-fed random wire antenna. So the KM4CFT end-fed kit is based on the work of Adam Kimmerly, K6ARK. And the difference is that it sacrifices a bit of size to make it significantly easier to assemble by spreading out the components a little bit and also making them all through hole. The kit can be made into either an end-fed half wave or an end-fed random wire. And in this video, I'll be showing you how to do the end-fed random wire variant. And so to build it, you're going to need the following tools. You're going to need some flush cuts. You're going to need some needle nose pliers. You're also going to, this is going to be useful, you're going to want a set of helping hands, a soldering iron with solder, and that should be everything except for maybe a hobby knife or some sandpaper for removing the excess, but that is not necessary. So what we're going to want to do is, first thing we're going to do is take a look at the kit, and we're going to make sure that we have everything. So the first, you should have your circuit board. You should have 6 inches of 26 gauge Polystealth, 18 inches of 28 gauge enamel copper wire, a BNC connector, a 100 picofarad 1 kV capacitor, an FT50-43 toroid, and some 3/4 inch heat shrink tubing. Now, since we're building the end-fed random wire, you can take this and discard it or throw it in your parts bin. We won't need it. So I'm going to put that off to the side. So the end-fed random wire, just some facts about it. It's a non-resident antenna. So if you're going to build this, make sure you have an antenna tuner or a transceiver that has an antenna tuner. So this would be great if you have something like an Elecraft KX2, KX3. The new KH1 will probably work. I haven't tested it with it, but I am 99% sure it will work with that. Or you have the Xiegu X5105, X6100, or the G90. If you use the G90, just make sure you only do QRP power with it. And without further ado, we will get started. So I'm going to go ahead and turn on my soldering iron. This is going to need a counterpoise. So unlike the end-fed half wave, you absolutely need a counterpoise. So we're going to bend the wire in half. We're going to take our flush cuts and cut it into 2 equal pieces. Okay, and then on each piece, we're going to cut off about 1/8 of an inch of insulation. Like that. Okay, I'm going to push some of this off to the side. So when we look at our board, there is 2 points. There's one that says CP and one that says ANT. They're both square holes or square pads with a circular hole. The ANT is for the antenna. The CP is for the counterpoise. You will also notice that there are 4 holes around the TR1. These are for strain relief. So the wire is going to come in and it's going to pass through these 2 holes and form our strain relief. So we're going to want our wire to come in from the top like this. So I'm going to situate this, and apologies, I'm not very good at filming this stuff, so I'm going to try to make this as good as I can, but this isn't my specialty. But yeah, we're going to have it like that. We're going to flip it over. This is where your helping hands will come in handy. No pun intended. All right, like that. Turn off the soldering iron because we're not going to need it anymore for a while. We're going to want to check that and make sure that everything's all good. If there's any excess, we don't want to take our flush cuts and clip off any little bit of extra. There shouldn't be that much. Okay, so now we're going to feed these through the strain relief holes. So they'll pass through like that. And it's going to pass up through here. I'm going to flatten that out like that. And then we're going to repeat for the other side. All right, so as you can see, it passes through those strain relief like that, on the bottom side like that, and we're all good to go. So we're gonna have to put this to the side for a little bit, and now for the part I'm gonna probably struggle a lot with is showing you guys how to wind the toroid. And what we're gonna want to do is take our magnet wire and unfurl it and straighten it out like that. I want to take out our... All right, with this, it's going to be a little bit tricky because traditionally when you make a random wire antenna, it's just you take 3 wires and you'd wrap it 9 times and call it good. With this, we're going to be doing a little bit slightly different. We also need to be careful as there's not, you only have 18 inches of wire, so you might have to be careful and make sure you don't have too much of a pigtail. We're gonna do you need to do 8 to 10 turns around this to start with. First things first, let's do, or I'm gonna do 9 turns. So I have, let's see how much I've given myself. This is about as much as you want to do. So at most, give yourself about ½ inch of pigtail. Then we're going to wrap 9 turns. So we pass through the center. Every time you pass through the center of a toroid, that's 1 turn. So that's 2. Three. 4. 5. 6. 7. 8. And 9. Like that. What we want to do is we want to try to spread our wrappings around evenly. Okay. The next, so that's lap 1. Lap 2, we're going to want to continue this, and then we're going to add a loop. So, 1 sec. All right, so we're going to want to continue this wrap. Then we come up over here. So now, if you've noticed, we've passed that first pigtail, and after we pass that first pigtail, that's where we're going to want to add our little loop here. I'm going to form a little pigtail there. And what we're going to want to do is we're going to want to take our needle nose pliers and form some, and we're going to twist the wire like that. Pull up, and then we're going to want to form, and we're going to want to follow the wire along. To make our second set of windings. And I would recommend being a little bit careful and trying to keep this as neat as possible. It'll make it easier on you since this is a small toroid. And one way you can make it also easier is rotate the toroid as you follow along. So you can see I'm kind of turning it as I do this. If we look here, let's count. Let's make sure we should have 18 turns at this point. So 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, so that's lap 2. We've completed lap 2. So that's lap 2. And for lap 3, all we got to do is, instead of adding a loop like this, we just continue along, and we should have that. And as you can see, I'm trying to keep it relatively neat. You can see there sets of 2. So we'll just keep on going. Straighten that out a little bit so that they're all grouped together. It's not necessary for them to be grouped together like this, but makes it easier to count. You have them in groups of 3 like this. All right, so we should have 27 turns if I did this right. So there's 3, 6, 9, 12, 15, 18, 21, 24, 27. And with that, we have our toroid complete. And that's the hardest part of this. When you look at it from when I stare at it on the left side with the loop, it should be on the outside of the toroid. This is going to be our input. Then it should be on the inside another one that's going to be our ground. And then on the right side is going to be our output. And of course, count your windings like I did. And now we're gonna move on to soldering it onto the board. We want to strip the enamel from this copper wire. There are 2 main means of doing so. One's with mechanical and the other one's with heat. Mechanical, you can use a hobby knife, or you can use sandpaper. Heat, you could use some kind of flame, or you can use solder. All 4 of those methods work great. I've tested them. They're all good. I like to do a combination of 2. I like to use a hobby knife along with the solder to finish off it. What I'm going to do is I'm going to take my hobby knife and I'm going to scrape it. Okay, so Now that we've done that, I'm going to take my pliers and I'm going to make sure that the nub is completely flat so that it'll fit through the holes. And we're going to move on to this. When we look at this, it's going to end up like that. There are 3 holes. There's this one, and this one for TR1. This one is our input. This one is ground, and this is output. So what we're going to want to do is we want to line the holes up and stick it through. Note that the loop should be connected to the input. So we're going to squeeze that in place, and then we're going to kind of pull everything flat. So you can see also there's labels on the bottom side. So you can see the loop is connected to input, and there's output and ground. All right. And then I'm going to take my helping hands to hold it flat. I would recommend making sure your soldering iron is hotter than usual. And what we're going to want to do is we're going to use a solder to melt or burn away any extra enamel that was left behind. So we're going to add solder and let it dwell for about 10 seconds. You'll notice that it'll be bubbling. Once the bubbling stops, you know you melted away all the, you burned away all of your enamel. So we'll measure it from around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll split. All right, good. That's good. Now what we're going to do is we're going to take our flush cuts and we're going to trim off the extra wire like so. If you want to, you can take your take some isopropyl alcohol and wipe off all that flux. We should be all good. The final step is we're going to want to install our BNC connector. So I'm going to bend it out a little bit just so that it has some tension. And you're going to drop it in place. And this is where having your helping hands really comes in handy. So what I do is I place the BNC connector on there like so. And instead of what you normally expect to do is you'd solder from the bottom, but I'm going to solder from the top like this. So I come in, I solder that center pin from the top, and if you're lucky, and usually this ends up happening, it'll solder the bottom too. So if we flip it over, you can see the bottom ended up getting soldered too. And then finally, what you do is we can solder these pieces in place. This is the part that takes the longest. If you have a bigger iron tip, that might be helpful as well. But what we're going to do is we're going to feed it some solder, and this entire BNC connector is metal, so a huge piece of metal has to get up to temperature before the solder will flow properly. So you're going to have to be patient and let it sit for a little bit. And with that, we have finished soldering on everything. If you want to be careful because that BNC connector is super hot. But now that we've done that, everything should be good. What we're going to want to do is, if you want to, you can test this by running a 450 ohm resistor across the counterpoise, the antenna line, and it should read on antenna analyzer to be about 50 ohms. But you don't need to be terribly accurate with your wire lengths. The goal of an end-fed random wire is that you want your antenna to not be equally not resonant on all the ham bands. So you're trying to avoid a half-wave multiple length, and the idea is that it won't be resonant on all the bands, but it'll be close enough to resonance where a tuner can bring it in. So there are various sources for recommended antenna lengths. One of which that I recommend looking up is if you look up end-fed random wire antenna lengths, you'll find a article by the University of Delaware, and it shows recommended lengths. So what I typically have is I want mine. Usually I'm using 40 through 10 meters. So I have cut myself a 35.5 foot radiator length and a 17-foot counterpoise. 17 feet seems to be the common counterpoise length in general, so recommend going with that. For the sake of the video, I'm going to go ahead and I'd recommend testing it, like hooking up your antenna wire and testing it, make sure you can actually it actually works. But for the sake of the video, I am going to go ahead and install the heat shrink tubing. Okay, I am back. The BNC connector is still hot, so I'm going to use some pliers to hold it. So I'm going to go ahead and slide on my heat shrink. Okay, like that. And I do not have heat gun. If you have a heat gun, use that. But that should be good enough. Now we've got that in place. I recommend if you get confused about it, use the guide to keep track of which one's the counterpoise and which one's not. I believe if I've got this memorized properly, when you have it with if you have the BNC connector to your left, the bottom one is your radiator and the top is the counterpoise, if I'm remembering correctly. So with that, I will congratulate you on building your KM4CFT end-fed half-wave, and I hope you have a lot of fun on your QRP journey. The last thing I will point out, if you want to have a 3D printable winder, I actually recommend the winder that Adam Kimberly designed. You can find it on Printables. And what I've done is, here's what I've done. He has three versions. One's for one's no clip, one's a female BNC, and one's a male BNC. I took the female BNC and a no clip and kind of merged them together. You can see how it's just 2 in 1. And then what I can do is it will clips into place like that. And the reason why I recommend this type of design is because you can have one side for your radiator, one side for your counterpoise. It keeps everything nice and neat. And I recommend that you use something like I use a hair tie as a way of securing it once I'm done. Okay, so I'm at Sheffield State Park and I've deployed my end-fed random wire. See down here, I've done is I've taken the ends and I've added little crimp-on connectors. What I like to do is add a colored piece of heat shrink on the side that's for the antenna, just so that I can keep track of them. See, I've done that with the radiator too. So I've got that. I got 35.5 feet running up to this Gocher Goldite crappie pole. And I've got 17 feet going that way. It's just above freezing out right now, so I'm planning on doing my little activation in my car. So I've just got the coax running into there, and I'll be right back and we'll take a look and see that it tunes on all the bands. Okay, so I'm going to test to see that it tunes on 40 through 10 meters. So I'm on 40 meters right now. So if we put ATU, okay, it tunes. We'll go here. Test it again. Tunes. 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 And we're good. So it tunes. After this, I will go and we'll do a little test on 20 meters and see that I can call CQ, POTA, and we'll be good.
Alright, thank you, 7-3. KB9VDR, parked on the air, Unun.
Kilo Mike 4, Charlie Fox Tango, park to park.
So Charlie Fox Tango again?
Kilowatt Mike 4, Charlie Foxtrot Tango, park to park.
Kilo Mike 4, Charlie Foxtrot Tango, 5-1 Wisconsin, parked for Kilo 10054 and Kilo 4238. Back to you.
QSL, copy the 4238. You are 5 and 7 to park Kilo 1212, park Kilo 1212 in Colorado.
Okay, I heard Colorado. Can I get your park number again?
Kilo 1212, park Kilo 1212, QSL.
Alright, I got the Kilo 1212 in Colorado. Thanks a lot for the park today.
7-3.
November 1, Papa Romeo Romeo.
November 1, Papa.
And that was KB9 VBR from KB9 VBR antennas. Just happened to be on the bands right when I was setting up. So as you can see, works great. So I hope you all enjoy your KM4CFT and Fed random wire antenna 7.3.